Okay guys, this is section 3.3, which is going to continue with truth tables. We're going to work on the conditional and the biconditional. Besides just working on the conditional and biconditional, we're also going to learn about self-contradictions, tautologies, and implications. Okay, so the first situation that you need to learn about is the conditional. The conditional is the if-then statement. So you have to have a minimum of two statements. So P is going to be your typical true, true, false, false. Q is going to be your true, false, true, true. And then if P then Q is going to have the following condition. Note that there's only one time when if P then Q is false. The only time if P then Q is false is if you start with a true and you finish with a false. Then you get a false. Every other instance, true, true, and false, false, will give you a true statement in the if P then Q situation. So again, you might want to write that rule down, write this table down, and use it when you go to complete your homework because you're going to be expected to have that memorized. An example of a conditional would be the following. Construct a truth table for the statement, if not P, then not Q. Okay, so let's try to complete this truth table. I'm just going to shrink this up so we have a little more room. Scoot that up here. Okay, so again, we have two letters that we're using. We have statement P and we have statement Q. So since there are two statements, then that means there's going to be 4 rows in your truth table. And your first statement will always start off true, true, false, false. Your second statement will start off true, false, true, false. Okay, you're going to have to first find the left-hand side, not P. Then you're going to have to find the right-hand side, not Q. And then you're going to have to find not if not P, then not Q. Once you have all that done, you'll the answer in the last column will be your truth table values. Okay, so not P, you're just going to take the P column and reverse everything. So instead of true, true, false, false, you're going to have false, false, true, true. For column Q, you're going to look at your Q column. Instead of true, false, you're going to have false, true, true. And then to do the if not P, then not Q, you're going to have to look at the relation. So remember, if you can't remember, if you go back to the previous slide, the only time this is false is if you start with the true and you finish with the false. So this situation right here, we start with the true and we finish with the false. That's going to be false. Everything else will be true. Okay. All right, the biconditional statement is your if and only if. And this is just them writing a proof of the if and only if. In order for P to be true if and only if Q, this is two conditional statements. If P then Q, and if Q then P. So they're writing this truth table here. You can just focus on the green column, okay? The biconditional statement is true as long as P and Q are both true, and as long as P and Q are both false. If P and Q agree, then the biconditional is going to be true. Otherwise, it will be false. Okay, so if you wanted me to write that a little more clear, I can say your P values can be true, true, false, false. Q can be true, false, false. P, if and only if Q, will then be false, true. Sorry, I wrote that wrong. Will be true, false, false, true. Okay, so remember, when you have true, false, 2 trues or 2 falses, you're going to get a true statement. Okay, so let's see that in action. Construct a truth table for the following statement. Not P, if and only if, not Q implies R. Okay, so this one's a little more complex, but we can do it. So I'm going to shrink it up. Notice that you have 3 statements here. You have a P, a Q, and an R. Okay, so that's going to make your table a little bit bigger, but we can do it. So we need a P column, a Q column, and an R column. Okay? We are going to have to figure out our left side of the equation, which is not P. We're going to have to figure out our right side, which is going to be not Q, and then not Q. If not Q, then R. And then we're going to have to do the one in the middle, which is not P if and only if not Q implies R. Okay. Since we have 3 statements, we are going to need 8 rows. Okay, so again, for our P column, start with 4 trues and 4 falses. Then for your Q, go down to 2 and 2. And for your R, go down to 1, alternating back and forth. Okay, now to get not P, all you have to do is look at the P column and do the opposite. So we'll have false, 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 true, 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 true. To get not Q, look at your Q column and do the opposite. So we'll have false, false, true, true, false, false, true, true. To get if not Q, then R, you're going to have to first look at your Q column, your not Q column, and then look at your R. And remember, the only time if thens are false is if you get a true false. So we have a false followed by a true, false, false, true, 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 false. That's bad. False, true, false, false, true, 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 false. That's bad. Okay, now you've got to put it together. You have to take the not P column, which is this one, and you have to take the not Q implies R column, and you have to do the if and only if statement with it. So remember, as long as they have the same symbol, you get to write true. So we have a false, true. That's false. False, true. False, true. False, false. There we had a match. True, true. True, true. True, true. True, false. And so this purple column over here would be your solutions column. Okay, you can also do this with applications if you want, and you don't have to make the entire truth column or the truth table when you're doing an application. You just need to make the row that applies. So you actually have to research and see if the statement is true or false. Okay, so I have a couple slides up here, so I'm going to start up here. The graph on the next slide represents the student population by age group for 2009 for the State College of Florida. Use this graph to determine the truth value of the following compound statements. Okay, so I'm looking at the pie graph over here. Okay, so it's showing you the percent of students that are younger than 21, those between 21 and 30, those between 31 and 40, between 41 and 50, and those older than 50 years old. Okay, now the question says the following. If 37% of the SFC population is younger than 21, or 26% of the SFC population is age 21 to 30, then 13% of the SFC population is age 31 to 40. Okay, so first thing we're going to have to do is we're going to have to label everything. Okay, so they had 3 statements here. So the first statement said 37% of the population is younger than 21. So let's call that P. P. 37% of the population is under 21. Okay. Their second statement said 26% of the population is between 21 and 30. So that's my second letter. 26% of the population is between 21 and 30. My third statement is that 13% of the population is between 31 and 40. So that's my third statement, R. 13% of the population is between 31 and 40. Okay, so with that, we should be able to pull this phrase apart now and translate it. So it says, if, so that's your implication one, if 37% of the population is younger than 21, or 26% of the population is age 21 through 30, then. Okay, so notice we just now got the then. Okay, so all the stuff that came before the then needs to go on the left side of the if statement. Okay, so 37% is my P, or 26% is my Q. So if this, then 13% of the SFC population is between 31 and 40. So then R. Okay, so we can use the graph to figure out the truth value of everything. Is it true that 37% of the population is under 21? That is true. Is it true that 26% of the population is between 21 and 30? That is false. Okay, so if P is true and Q is false, what can we say about P or Q? Based on what we learned in the last section, only one of them has to be true. So this whole left-hand side is true. Now what about R? Is it true that 13% of the population is between 31 and 40? That is true. So the left side is true and the right side is true. So is the if-then statement true? The if-then statement will also be true because the only time the if-then statement is false is if you get a true-false. Okay? You can do repeat this problem with another example if we want. So we're going to use that same chart. Okay? So 3% of the population is older than 50. Let's let that be Q. Sorry, P. 3% is above 50. 8% of the population is between 41 and 50, so that's Q. 8% is between 41 and 50. If and only if 19% of the population is between 21 and 30, so that's my R. 19% is between 21 and 30. Okay, so let's pull this apart again. 3% of the population is older than 50. And 8% of the population is between 41 and 50. If and only if 19% of the population is 21 to 30. Okay, so again, you have to look at that table. Sorry, the table's on the last slide. So the first thing we would do is we would check to see if the population that's over 50 is really 3%. And that did turn out to be true. Then we would check to see if the population between 41 and 50 is really 8%. And that, if you look at the pie graph on the other page, that is also true. So then because we're doing an and statement between them, they're both true. So we get to go, the whole left side is true. Now let's see what the right-hand side is. Is it true that 19% of the population is between 21 and 30? And that is actually false because when you look at the pie graph, it's actually 39%. Okay? Because the symbols don't match, you can say that this is a false statement. Okay? And you have proven that using a truth table. Okay? All right, now a couple definitions. One definition you're going to run into is the word self-contradiction. A self-contradiction is a situation when you come out with a truth table. The truth table is always false. every single answer in your final column will be false, meaning no matter what you do, there's no way this statement will ever be true. Okay, so I can show you an example of that. Construct a truth table for the following statement. If P, if and only if Q, and P, if and only if not Q. Okay, so let's do a truth table like for this, and I can show you what it's going to look like. So I'm going to squish this down a little bit. Okay, I actually only have 2 statements, so I'm only going to need 4 rows because I only have something about P and Q. So then I'm going to have to figure out the right-hand side, which is P if and only if Q. Then I'll have to figure out the left-hand side, which I'm going to have to figure out my not Q first. And then I'll have to do P if and only if not Q. And then I'm going to have to take the left-hand side and the right-hand side and do an AND statement with those. Okay. All right, so let's start with P. P is going to be a true, true, false, false. Q is a true, false, true, false. If and only if is true as long as they have the same symbol. So true, 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 false, false, true, and false, false. Okay, then I'm going to need to do my negation of Q. So that's going to be false, true, false, true. Then I'm going to have to do P if and only if the negation of Q. So true, false, true, true, false, 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 true. Okay, and then the 2 that I have starred, so I have this one starred here and this one starred here. I'm going to have to do an AND with those. So remember, they have to both be true. So I've got a true, false, a false, true, a false, true, and a true, false. Uh-oh. So there it is. See how you got the column of falses? That is a self-contradiction. Okay, if you ever get that. Now, the other thing that is you can get a tautology. A tautology is the exact opposite of a self-contradiction. In a tautology, you get a column of all truths, meaning every single statement will come out to be true based in this situation. So I can show you an example. Okay, construct a truth table for the following statement. P and Q, if P and Q, then P or R. Okay, so let's see what that looks like. I'm going to shrink that down. Okay, this one has 3 statements, P, Q, and R. So we're going to need 8 rows. We need a P, a Q, and an R. So true, 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 true. False, 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 false. True, false, true, false. Ooh, I messed that up. Sorry. Let's fix that. I should have done 2 at a time. True, true, false, false, true, true, false, false. Now I can do every other one. True, false, true, false, true, false, true, false. Okay, I'm going to have to do my left-hand side first. So my left-hand side tells me that I need to do P and Q. Then I'm going to do my right-hand side, which tells me to do P or R. And then I need to take those 2 columns and compare them. So this column compared to that column. So the P and Q, if P and Q, then P or R. And we'll see what happens in that last column. Okay, so when I do the P and Q, remember I need them both to be trues. So I've got a true, true, false, 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 false. Okay, and then I'm going to do my P or R. So remember, the only time P or R is false is if you have two falses. So I've got true, 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 false, true, 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 false, false, true, false, false, that's a false, false, true, false, false, that's a false. Okay, now I need to put it together. So I need to compare my P and Q with my P or R, and I need to apply the if-then rules to it. So remember, the if-then, the only time you get a false statement is if you have a true followed by a false. So we've got true, 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 true. Everything else starts with false, so I'm going to have trues all the way down. And notice you get a column of all trues. That's called a tautology. Okay. More definition. The other definition is called an implication. Okay, an implication is a conditional statement that is a tautology. The consequent will be true whenever the anecdote is true. Antecedent is true. Sorry, my fault. Okay, so here's just another example. So this is a conditional statement. It's conditional because notice you have the if-then. And according to this, if we get all trues, this would be an implication. Okay, so let's see. We have P and Q, if this, then Q. That sounds really confusing. So let's take a look and let's see what that is going to look like here. Okay, I'm going to shrink it up. I'll show you one way that the book does this. Okay. The book will sometimes try and save a little bit of writing. So they'll go ahead and they'll write it out. P and Q in parentheses. And Q in brackets implies Q. Okay, so what the book will do is the column you get underneath the arrow is your answer. And they like to do it like this. They think it saves writing. So I'll show you. So for P, they put their true, true, false, false. And then for Q, they put their true, false, true, false. And they write that down for all the Qs. See how Q is listed 3 times? They will list this column 3 times. Okay, so then they'll complete the P and Q. Okay, so P and Q, remember they both have to be true. So I've got a true, true. Everything else is going to be false. So then they're going to take that column, my gold column, and compare that to the Q column. And that is also an and. So they're going to take those answers and produce a column under that. So true, true is true. Everything else is going to be false because of the and. Okay, so now they're going to take my red column and their last Q column and compare those in the if-then terms. So remember, the only time if-then is false is if you get a true and then a false. So I'm going to do that in purple. So I've got true, true, false, 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 true, false, false. So see how I got my column of T's again? That is your tautology. But because it is a conditional statement, then it's also called an implication. Okay, guys, good luck on your homework.